Good afternoon, everybody, and welcome to webinar 3 of our virtual masterclass series. And today we're going to be discussing, well, we're looking at comparing the new Enigma VSEP guidelines for BRCA1 and BRCA2 with our existing or current guidelines in this field of variant interpretation. Next slide, please. So my usual duties. So just a couple of housekeeping duties that we need to make you aware of. So we have automatically muted your microphones to avoid any background noise. Please do try to keep your microphones turned off at all times. We are recording the webinar, so hopefully we should have that webinar available to you for you to review at your leisure on the GenQA and EMQN YouTube channels sometime in the next 3 or 4 months at the latest. So if you can't make it today, then obviously you will be able to, or your colleagues will be able to pick it up at a later date. And as always, these webinars and virtual masterclasses are supposed to be interactive, and we strongly encourage you to contribute and ask questions of today's speakers. So you can use the Q&A function to submit your questions. We've got about an hour or so of overview and review of the guidance. And then time allocated at the end for some questions and answers. So please do use the Q&A function to submit your questions. Next slide, please. Your feedback has already contributed to us changing the strategies and the discussion we bring to you in our masterclass series. So we do value it. It's great, very important to us, and obviously it does help provide and ensure that we provide high quality educational and training materials for you and your colleagues. So after the webinar's concluded, you should receive an email with a short link to a feedback survey, no more than 5 minutes, usually 2 to 2 minutes to complete it. Please do take time just to compute that feedback and contribute to our own learning as well, if you like, from what we've been delivering to you. Next slide, please. So my name's Simon Patton, and together with my co-host, Professor Sandy Deans, you'll be very familiar with both of us. We've got a fantastic webinar lined up for you today. 2 great speakers, really knowledgeable, got lots of experience in this field. So we have Claire Turnbull from London in the UK, who's the CANVIG lead and supported by a CR UK grant, been working in the cancer community area and particularly on variant interpretation for a very long time. And Arjen Mensenkamp from Nijmegen in the Netherlands, who has been working on the Enigma VSEP group as well. So lots of experience here between the 2 speakers, both incredibly knowledgeable and lots of experience in this field. And I think you'll really enjoy today's talk and find it highly educational. Next slide, please. So just a quick disclaimer. Next slide, please. And I'll hand over to my colleague, Sandy Deans.
Thank you, Simon. So I'll just add my welcome to everyone to today's very exciting webinar with our expert panel. So pleased that both Claire and Arjen could join us today. So what we're going to focus on is really starting to build upon the observations and the learnings and educational element of the external quality assessment modules that we've been providing for the classification of variants within not just BRCA1 and BRCA2, where we first initially started, but also with expansion on the other HRR genes. And I think we've come to some understanding that it's difficult to classify these variants, in particular when there's different guidelines, different sources of ways how to do this. And one of the, Simon says, responses from a lot of participants was, can you give us some guidance of which guidelines we should be using and how to apply them in the most appropriate way? So hence we have our workshop today, and hopefully we can get some good questions happening at the end of the session. So next slide, please. So we've already completed an external quality assessment run for variant interpretation in 2023. So this was run 10 and was completed earlier in the year. So one of the power of providing external quality assessment is you can actually gather information on what is happening in the real world. Now, whether that's methodology, testing strategies, the way people report results, that it also comes down to how people classify their variants and which guidelines they use. So here is just a snapshot and summary of the guidelines that have been used by the participants, which was nearly 600 individuals globally, across the 6 cases that we provided for run 10. So no surprise, the majority of individuals, 41%, were using the ACMG 2015 guidelines that we know and use so much and expansively across the whole of genomics. We had 13% of individuals who were using these guidelines and also the UK ACGS 2020 guidelines. We also then had an increase of participants from previous years using a combination of 3 different guidelines, and this included the CANVIG UK guidelines, and then we had 13% who used other different sources of recommendations. So Claire, can I ask you to come in here and comment on how really the CANVIG guidelines in the UK evolved and what the purpose was for them?
Yes, thank you, Sandy. So CANVIG UK is Cancer Variant Interpretation Group UK, and this started up in 2017 at the request of ACGS, the Association of Clinical Genomic Science, around specifying and educating and training around what was then the new ACMG guidance. And what, as CANVIG evolved, one of the things we did was produce interim gene-specific guidance while we've been awaiting the finalized versions coming out from the VSIPs. So the BRCA1, BRCA2 CANVIG guidance was very deliberately interim. However, with the publication of the Enigma VSIP earlier this year, there's been some hesitation within the CANVIG group about switching over immediately, because we know that there's the new ACMG guidance looming on the horizon. But I think it's useful to emphasize that CANVIG is not, we don't per se want to have separate guidance from the Enigma VSIP. So we'd really be looking, as the new ACMG is embedded and the Enigma is updated accordingly, to then at that point get the UK community crossed over so we're all lined up.
Great, thank you, Claire. I think that's a worry people are concerned about. Were we using the wrong guidelines? Should we be switching? And so some guidance there is really helpful. Thank you. So next slide, please. So as I mentioned, we can sort of gather the information in the real world. And when we compare that data that I've just demonstrated, that you can see from previous years. So last year, we had runs 8 and 9 of the variant classification. We had 41% of participants using the ACMG guidelines alone. So you can see there's a shift happening there. And as Claire very said just now, that we are all expectantly waiting for the update of these guidelines that we are hoping will come out for consultation later this year. And the latest we've heard is that is still on track. So hopefully we'll be able to give you messaging when we have notification as well, and we'll be able to see what the changes are to be applied. So next slide, please. So as Claire's mentioned here, we've got our ACGS 2020 guidance. We also have then the different CANVIG UK guidance that have been issued, not just the general one, but also gene-specific guidance. And that's then also been supplemented with the ACMG classification rules, which is specifically for ATM. And then very recently, we've had the ClinGen variant interpretation guidelines for PAL-B2. And then next slide, please, Amy. We've also got the very recently released Enigma guidelines for BRCA1, BRCA2, which is the BRCA2 version there. So you can see that things are evolving. It is a moving feast just now. And I think there's no reason to be ashamed that everyone is struggling with which guidelines to apply, because it's getting more and more complex and more specific as we move through different variations of guidelines being published. So next slide, please. So which guidelines should be used? This is the question. So guidelines do continue to evolve. And as we've just been mentioning, we're expecting even more updates coming very, very soon. So the most current guidelines that are in play just now is the Enigma guidelines, which was published in 2023 for BRC1 and BRC2. You have the ACMG classifications for ATM. You've got the CANVIG UK classification recommendations for CHEK2, And then you have also the ClinGen ACMG for PAL-B2. So hopefully that will signpost you into what is the most recent and up-to-date guidelines for gene-specific variant interpretation. So next slide, please. So I'm now going to hand over to our second expert, Arjun, who is going to explain the Enigma guidelines here. Thank you, Arjun.
Thank you, Sandy. Indeed, I will discuss this today with you, the ClinGen Enigma guidelines. They were recently published thanks to enormous work by Mandy Spurdle and Michael Parsons, especially from Australia, and the whole Enigma team. If you're questioning where can I find the guidelines, you can find them in the Criteria Specification Registry. Could you please click that link? It will open there exactly here at the CGR. You can find all the guidelines, and completely at the end of the page, you can find very important, enormous amount of appendices, 50 or more pages, but even more important, the table 4 and 9 you can find there, and they are very useful, and I will mention them in my talk later on. But you can find them there in the guidelines completely at the end. So next slide, please. I will just start with PVS1. PVS1, you know, is important for null variants, nonsense, frameshift variants in genes where loss of function is a known mechanism of disease. Next slide, please. For the ACMG guidelines, the first version was quite rude, and later on it was extensively adapted by Tayoun et al., in which they made a very nice flow scheme. And it's always hard to read, but you probably know it. It is divided into nonsense and frameshift variants, splice site variants, and exon deletions. And following a path will lead to a classification. Next slide, please. For nonsense and frameshift variants, especially in the 3' end of a gene, it is important whether or not nonsense-mediated decay is expected. A nonsense-mediated decay appears when during translation appears an exon junction complex after a stop codon, which you would not normally expect, of course. But if a exon junction complex is detected after a stop codon, the transcript is degraded by the LND pathway. If a stop codon happens in the last exon, obviously that doesn't occur, and you still have a protein, albeit a little bit shorter. And so therefore it depends a lot whether you can apply PVS1 or not, or at which level. And for BSC1 and 2, actually, we have much more knowledge. And we have a last well-described pathogenic variant, and this is for BSC1 leucine 1854. This variant will not result in nonsense-mediated decay, but we know it is pathogenic. So on that basis, PVS1 was modified. So until that level, it is strong. PVS1 at very strong level, upgraded from strong compared to the Tayoun guidelines. And if you have a stop mutation, a stop gain variant after that amino acid, you cannot apply PVS1 at all, which is a downgrade from the Tayoun guideline. So there's a very strict border. And of course, it doesn't say that the variant after that spot is not pathogenic, but we have no information on that. Or if it is pathogenic, the penetrance will be much lower. Next slide, please. For exon deletions and duplications, and here I give the example for BSCA1, application of PVS1 depends on the type of mutation and the location. Generally, loss of an exon in an important functional domain is always pathogenic, whereas an in-frame deletion outside these domains is not, or not likely at least, and therefore there was a downgraded PVS1 indication to moderate for those in-frame deletions. Next slide, I think, is a pop-up to indeed, that both BSCA1 and BSCA2 have intrinsically disordered domains, and in-frame deletions in those domains are quite tolerant. Next slide, please. For BSCA2, the story is not much different than BSCA1. So an in-frame deletion in the PALB2 binding domain or the DNA binding domain is generally pathogenic, so you have a PVS1 very strong. And if your deletion occurs outside these domains, it depends on the circumstances whether it is very strong as a code or whether it's not applicable. And that is when a deletion occurs when exon 11 is not implicated. And we have very good support for these rules. And next slide, please. And next slide. Because of functional studies that have been done in Leiden in the paper, in the Messman et al. Paper, in which they tested the BSCA2 gene with certain exons deleted. And for example, if you look at the exon 4 to 7 deletion, which corresponds to a naturally occurring isoform, the homologous recombination activity is still 100%. So here you can see the deletion of certain exons appears not to be pathogenic or not fully pathogenic. So it's important to keep in mind that an exon deletion, in frame exon deletion, is not always pathogenic. The next slide, please. If you talk about splicing, things always get more complicated. And there it depends largely on the location and the effect on the protein. Again, here damage, a splice variant that is damaging one of the important domains is generally pathogenic. All possible splice variants at the consensus splice sites are also given in the appendices of the guidelines and table 4 of the guideline. I will come back to that later. But it is therefore, there's so many exceptions which exon can be is needed or not, or what the effect is of a splice site variant. And to make it more easy, we summarized everything in Appendix E, but also in Table 4 of the guideline. Next slide, please. And then we had a request for, if you follow these rules without much clinical data, you notice that you will not get much further than a likely pathogenic variant. And especially for circumstances that you have secondary findings, so no true cancer clinic, it is especially in the US vital that you can reach a truly pathogenic classification. And for that purpose, we used a repurposing of the PM5 code, the PM5 protein truncating code. The PM5 code originally is a missense change at an amino acid residue where a different missense change determined to be pathogenic has been seen before. It's not applicable for BSA1 and 2, but it is with this protein truncating addition. Next slide, please. And it is much easier to reach pathogenic with this extra code if you do not have any clinical evidence. Next slide. And that was really determined by really counting all known pathogenic variants in all the exons of BSA1 in this case, and stating the number of pathogenic variants in an exon. If you have, it is just behind the idea that if you know that in a certain exon pathogenic variants occur, truncating variants or missense variants with a pathogenic effect, then you can quite safely assume that your novel truncating variant in that exon is also pathogenic. And then you can apply PM5 at a strong level. You notice here exon 8 and 9 or 9 and 10, according to the legacy counting, truncating variants there are not, has not been seen, are not known. And therefore you cannot apply that code. And it is very questionable if you find a truncating variant in one of those exons that it is truly pathogenic. For BSCA2, on the next slide, that is a comparable story that truncating variants were counting, or pathogenic variants were counted in all these exons. And here you also note that in some exons, but not that many, either you cannot find those variants, or those variants were not pathogenic in certain exons. And therefore you cannot apply PM5 in those exons, but for the vast majority of exons, and that makes sense, a truncating variant is likely to be pathogenic, and therefore you can also apply PM5 protein truncating. So then normally you will have a PVS1 together with the PM5 strong, and you will end up with a classification of the variant being pathogenic. And this is quite novel for this guideline. Next slide, please. So this is a screenshot of the table 4 that I mentioned. And the first time you see the table, it might be a little bit confusing, but you can all filter, you can search in this table, and it indicates which domain you are, but it also indicates whether a variant PM5 can be applied and at which strength, whether a deletion of an exon can be seen as PVS1 or not. And on the left-hand side, on the right-hand side of the table, you also see information on the splice site variants, on the 1 and 2 dinucleotide intronic variants, whether you can apply PVS1 or whether you or not. And I will come back to that later. So this table, I will come back to this a couple of times more, and is really useful as the guideline is sometimes very confusing whether or not a truncating or splice site variant is pathogenic, or can be, whether PVS1 can be applied or not. And this table is made to make your life a little bit more easy, although it does also take here a bit of, you have to get used to it, just by using it. Next slide, please. That brings me to another novel application of PVS1, the PVS1 RNA. And PVS1 RNA replaces the code PS3 for splicing as detected by RNA assays. And the BP7 RNA is of course, the counter version of it for if you do not detect any splicing defects. Next slide, please. And this code, we had to use this code because of the paper by Walker et al. Well, Walker is also a member of the BSc1-2 VSEP, and most of the authors actually are also member of the BSc1 and 2 VSEP. And they made new recommendations how to apply RNA variation and RNA assays in your guidelines. And basically, you see here below a certain a screenshot of a gene, and whether you can apply, if this exon is deleted, which PVS1 code you can apply. If an exon is out of frame, and you can recognize that the left side and the right-hand side of an exon has a different format, then you can apply PVS1 because you have an out-of-frame effect. An intronic and an in-frame deletion is only PVS1 when a critical domain is involved. But if there is no domain involved, or at least not a domain with a known function, you have to reduce the strength to strong or moderate. Well, this is the basis also for the splicing. You can see that in the right-hand corner, there are multiple codes that you can apply for prediction of splicing prediction, and also for splicing assays. And we applied this information also to the BSc1 and 2 guidelines. On the next slide. Yes, again, coming back to that Excel table 4, in which this all information is summarized for each exon of BSc1 and 2, so you don't have to think about it yourself. Next slide. This is then, of course, the next question is how to interpret your RNA data. And the first step in that is, can you show me the next pic, is that you look up in this table 4 whether loss of that exon is indeed PVS1 or does it have a lower strength, PVS1 strong or moderate or supporting. And that is your starting point. And then you look at your data, and if you have an assay which does include allele specific quantitation, and you see less than 10% of your wild type allele, then you can keep a PVS1 strength for RNA, in this case, for your variant. And if you only have mini-gene information, you will lose your strength, and also you will lose also strength if you still have some wild type transcript present. Then you will see that your strength for PVS1 will decrease to even PVS1 moderate or supporting if you can still see about 20% wild type allele present. If you see more than 30% wild type allele still present coming from the transcript with the variant, you can even apply BP7 strong, as that is quite certain not a pathogenic variant, as we know that about 30% transcript from your allele is still enough for proper HRD function. So it's complicated, but normally, yeah, you really have to be sure that you lose most of your wild type allele, and if so, you can apply PVS1 RNA at the highest strength. Next slide. If you do not have a allele-specific quantitation, next slide. And that is, for example, if you use Sanger and you do not have any evidence how much wild type allele you still have present, you can you already have to reduce your strength. So at the maximum PVS1 strong RNA, if you have as far as you can say, full loss of your exon due to the splicing variant. And if you have apparent no impact, of course, you can apply BP7 strong RNA. And so in that way, you can, this is, I think, for the Canvic rules, comparable to the PS3 RNA adaptations. Next slide. And again, for the third time, look at table 4, where this is explained also for these variants. You can see here in red, both on your left-hand side for the acceptor variant, and on the right-hand side for the donor variant. In red, a PVS1 RNA, and that means that in literature there is functional evidence that this variant leads to a loss of an exon, in this case exon 26, and which is pathogenic. Then next slide, please. Yeah, like I said again, here on the left-hand side and the right-hand side of this table 4, you can find the information you need to see which code you can apply for your intronic variants at the 1 and 2 dinucleotide positions. To make life a little bit easier, but also more complicated, there is also a novel adaptation of the PS1 code. PS1 you normally apply if your nucleotide change gives an amino acid change that is already known to be pathogenic. This code has now been adapted for RNA, and you can apply it for exonic and intronic variants with the same predicted impact on splicing as another already known pathogenic variant. Next slide, please. And this is a table from the appendices, and it explains that, for example, if you look on the left-hand side, a variant under assessment, VUA, so that is the variant you identified, if it is located outside the 1,2 dinucleotide position, and you have a PP3 prediction, so you expect it based on your Splice AI data that it will lead to a splice defect. And if you have a known pathogenic variant at exactly the same nucleotide but different change, you can also apply PS1 as an additional code. However, you must be certain that the pathogenic variant or your variant under assessment gives a same or higher Splice AI prediction to be sure that you can indeed expect the same effect as the known variant. And as soon as and you have a downgrade of PS1 under different conditions, for example, when your variant, the known pathogenic variant is not at the same position, but somewhere else in the same donor motif or same acceptor motif, and there you also have the comparable Splice AI prediction, you can still apply PS1 moderate. However, if your variant under assessment is located at the 1,2 dinucleotide position, you can only use PS1 supporting, and that is only for a bioinformatical reason, and just to prevent that your level of evidence gets too high for a single item. So you can only apply PS1 supporting, otherwise your level of evidence would be too high. I think this, and then again, please note that you can only use it if the effect of your variant under assessment is the same or stronger than the known pathogenic variant. Okay, next slide, please. I will give an example from run 9. This was in a missense variant at +6. For run 9, we applied for the CANVIC guidelines, a PM2 moderate. For the ACMG guidelines, you cannot do that. You can only go to supporting. I will present those data later. And for CANVIC UK, PS3 very strong was used. Why? Because loss of function was also observed in the saturation genome editing assay from Findley. And in addition, there was literature which showed that there was an mRNA effect by using of a critical splice site 65 nucleotides downstream. And therefore, that combination in the CANVIC guidelines, you used PS3 very strong. For the ACMG BSC1 and 2 guidelines, you can still apply PS3, but only for the part for the Findley assay, because that is a functional assay, so you can still use PS3 at a strong level of evidence. But in addition to that, you can use PVS1 RNA on the basis of the splice effect you see using the mRNA assay. So this is in total a stronger, more evidence, but in the end you will end up at pathogenic anyway. There was discussion on PS1, also for a 9. For the CANVIC UK guidelines, you could use a supporting level of evidence. And of course, for the ACMG BSC1 and 2 guidelines, you could use PS1, as I just explained to you. However, that is not possible because the pathogenic variant that was already known, which is +6 T2G instead of T2C, has a stronger prediction in Splice AI than the variant under assessment here, T2C. So PS1 cannot be applied as the Splice AI prediction is lower than the known variant. But still, there is you'll get too strong and one supporting. So that is more than enough evidence. Next slide. That brings us to the PS3 functional data code. So PS3 is, of course, applicable also in the BSC1 and 2 guidelines, and PS3 as well for a whole list of functional assays that have been approved by Enigma. Splicing data, though, from RNA studies, just moved to PVS1 RNA, as I just explained to you. So next slide, please. In table 9 from the guidelines, you will find all variants that have been tested in one of the Enigma approved functional assays. So you can just look up your variant in this table and you'll get the result. Obviously, that is a frozen moment for now, and I suppose there will be an update later on. But if there is an assay that is not in this list, that is possible, but then you have to work out for yourself whether this assay is appropriate. And so if you know that there is functional data on a variant and it is not present in this table, you can do it yourself. Next slide, please. Happily, this data is already present. So Burnage has presented a way how you can calculate the weight of your functional assay. And it is quite straightforward, but still a lot of work. And the CANVIC UK has done it for many functional tests already. Next slide, please. And they can be found here on the website of CANVIC UK. And there's a whole list of functional tests that have been burnaged for you. And then you know at what strength you can apply a certain functional test. Next slide. And this is the example from the CANVIC UK, what you can see for each gene, which functional tests are available, and what strength you can apply the PS3 and BS3 for your variant under analysis. Next slide. Next slide. And if you want to have more details on how to burnish your functional assay, I would like to refer to webinar 2, in which it was explained in more detail. Now we move to the frequency part. The frequency information can be divided in 3 categories: PM2, BA1, and BS1, as we already, of course, know. For PM2, next slide, please. We know more guidelines, and the ACGS guideline and the CANVIC guidelines already suggested use a moderate strength if a variant is not present in the NOMAD database. The ClinGen VSEP for BSC1 and 2 only applies PM2 at supporting level. However, they validated this data on the dataset for males and females together, the non-cancer males and females. So that's different from CANVIC UK that uses only the females. Next slide. And there is evidence for that. So a likelihood ratio was calculated for all likely benign variants in the data set, and 175 likely benign variants were absent in NOMAD versus 116 out of 140 pathogenic variants, which gives you a likelihood ratio of almost 3. So 3 times enriched pathogenic variants are almost 3 times enriched, and that is enough evidence for supporting, at least supporting PM2. The problem is that if you look at variants that occur once in NOMAD, this was not informative. 71 out of the 609 likely benign variants occurred once in NOMAD versus 16 out of 140 pathogenic variants. And that is exactly the same. So there is no enrichment for pathogenic variants in the category variant that occurred once in NOMAD. So that was the reasoning not to really keep the level at 0 occurrences in NOMAD. Next slide. For BA1, it is identical. The VSEP BSC1 and 2 is identical to the CANVIC guidelines, except for the fact that, again, CANVIC uses cancer-free females, while Enigma didn't look at that and included males and females together. Next slide, please. For the BS1, you can use the Witten calculator. Again, that this has been extensively explained in webinar 2. And using this Witten calculator, we also came up with the same level for BS1 strong. But in addition to that, using likelihood ratios, the VSEP was able to also apply a BS1 strength sub for variants that are less rare than BS1. So already at a frequency of 0.02%, BS1 supporting can be applied, which is very useful for those variants that are rare, but not rare enough. And so that is a bit more helpful. Next slide, please. I give an example for a missense variant from run 10 from the last run. In this case, BP1 supporting was applied by CANVIC, and that cannot be done via the ACMG BSC1 and 2 guidelines. And I will come back to that later, because this variant is outside any of the known important domains. However, you can, for that, use BP1 strong. That is completely at the bottom of this table. And this is a new code. And I will come back to that later again to explain it in more detail. So BP4 supporting could not be used, but you can use instead of that the BP1 strong. For this variant, we saw that it occurred once in a homozygous male. And for that, we used the Fanconi code or non-Fanconi code BS2 supporting, as it was in a healthy individual, which is one healthy individual in NOMAD, and therefore you could apply BS2 supporting. According to the ACMG VSEP guidelines, this variant, which occurred at a frequency of, well, this number, 0.08%, which is higher than the level for BS1 supporting, so you can apply BS1 supporting. And this has a higher prevalence than BS2. So you have a slightly different code, but at the same strength for the specific variant. And in this case, you easily come up at a benign level of evidence. Next slide, please. That brings us to PS4, and that makes it more complex. PS4 is for case control analysis. So the prevalence of a variant in affected individuals is significantly increased compared with the prevalence in controls. Next slide, please. If you look at case counting, which is still popular, especially in the UK, is not really allowed under the VSEP rules. Not for Check 2, not for ATM, and not for BSc 1 and 2. I put it in between brackets because the rules do not say you are not allowed to use it, but it is not recommended to use it. Next slide, please. And it is too complicated to really trust on case counting or proband counting, as it is also being called, for several reasons. Also because PS4 case counting, you have to use the zero. It needs to know that PM2 is applicable. And in that moment, you would use PM2 and PS4 together, and that would be double dipping, which is not allowed. So in the end, the VSEP concluded that it is unwise to stipulate specific criteria for BSc 1 and 2 to use proband counting, case counting for BSc 1 and 2. Keeping it in mind, this is also an American and also used, of course, in the US. In the UK, there is a specific use of the UK Biobank in which you have a proper control data set. So I'm not going to discuss that, but for these rules, it is, like I said, it was, we didn't make any specific criteria to use PS4 in general, but if you work out the details yourself, you can apply it. Next slide, please. For case control data, of course, you can apply it even at strong level of evidence, and it is if your variant is consistent with a high increased risk of cancer. So an odds ratio of over 4 and with a significant result. However, next slide, case control is preferably used on the PP4 in a complete multifactorial likelihood analysis together with other variables that you can use on the PP4. So, but you can use case control data sets, case control data also in the BSc 1 and 2 framework. Next slide. And here I would like to give the word to Claire for this slide.
Yes, so I was just going to give some details of how we specify PS4 in the CANVIG guidance. So in regard of a case control analysis, we allow a bit more, or we prescribe a bit more flexibility in the strength of association. So you can have stronger evidence for if the p-value is much stronger, and likewise some lower evidence points if the p-exact isn't meeting the 0.05 threshold. And that gives a bit more flexibility than that sort of single binary. You can either have strong or nothing. We took the ACMG cutoff of an odds ratio of 5. I think Enigma used 4 because that's sort of what was evolved in that 2015 Eastern paper as being a high penetrance breast cancer gene. We also specify around this is assuming you're using population data, so you're quantifying all unselected breast cancer cases. If you're using enriched breast cancer cases, we stipulate that you need to attain an odds ratio of 10 rather than 5. And then, as Arjun says, we do still allow some quite specific around the requirements for a low population frequency, but that you could have supporting PS4 if you have 5 or more HBOC families identified with a low control frequency, and or if you have 10 or more reported in the literature, and you have a absolute absence in UK Biobank or appropriate controls, then you could have moderate. So we do allow that, and we have updated our guidance, and that the new update will be released by the next round of the EQA. So we do specify that you shouldn't be using the same data set for your PM2 and your PS4, because, as Arjun said, this is then double counting. So that we would recommend using UK Biobank for PS4 and females, again, so it should be ethnicity match and gender match, and then to use Nomad for PS2.
Thank you. I will continue now with the PP5. And PP5 is the reputable source, and this code is no longer in use. As it is not an appropriate level of evidence. Next slide, please. But Canvig UK used this code strength to include the multifactorial likelihood analyses from Enigma. You had to put it somewhere, and they put it in PP5. However, the SVI, the big boss from all VSEPs, did not allow us to use that also for the VSEP BSc 1 and 2 guidelines, and therefore we put that in PP4. So exactly the same as for here for PP5, but then we call it PP4. That's the only difference. Next slide, please. So you can use likelihood scores. If it's strong enough, you can even use it at a very strong evidence level. And if it's low enough, you can use that support at very strong against pathogenicity. But this is exactly the same as in the Canvig UK guidelines, but only using a different code. Next slide, please. This is getting more interesting. PP3, that is the in silico data. Multiple lines of computational evidence support a deleterious effect on the gene or gene product. You all know this code. Next slide, please. However, you can apply it in different ways. The original guidelines suggested to use multiple tools. The Canvig UK guideline in 2022 suggested to use only Revel, and for PP3 using Revel over 0.7. For splicing, there were still a couple of assays that you can, a couple of prediction programs that you can use. Perhaps if you heard the news, now also Google has a protein prediction impact score. I haven't looked into that yet, but I suppose that will also be part of the guidelines in the next version. Next slide, please. And if you look at the ClinGen VSEP for BSc 1 and 2, unfortunately, I think they chose yet another prediction model, BaseDel, which was slightly better for BSc 1 and 2, and also better to predict the effect of indel variants, not only missense variants. And it was tested that the BaseDel score over 0.28 for BSc 1 and over 0.30 for BSc 2, unfortunately, not the same score. You can apply PP3. However, you can only do that if your variant of interest is within an important functional domain. If your variant is outside the functional domain, next slide, you can apply BP1 strong. I will come back to that later. So no Revel here, but BaseDel at about 0.3 as a cutoff value. Next slide. Yeah, BP1 strong. I mentioned it a couple of times. The original code is a missense variant in a gene for which primarily truncating variants are known to cause disease. For BSc 1 and 2, this is disputable. There are missense variants known to be pathogenic, but only inside the clinically important functional domains. Outside these domains, missense variants are rarely, if at all, pathogenic in any case. So if you have a silent substitution, a missense variant, or an in-frame insertion outside a potentially clinically important functional domain, and you do not expect a splicing effect, you can apply BP1 strong at a standalone. So BP1 strong alone is enough for a likely benign classification. Next slide, please. If your missense variant is inside a clinical important functional domain, then if you have a BaseDel score below 0.18, you can apply BP4. And if this variant is a silent variant inside the clinically important domain or outside the acceptor and donor motifs, you can also apply BP7. And this is identical to Canvig UK guideline. Next slide, please. So again, outside of these domains, you can just use BP1 strong, standalone, likely benign as evidence level. Next slide. And then we have got a couple of other codes, and like PM1, speaking about important domains, PM4, if a protein length of a protein is changed, or PM5, if you have a novel missense change at an amino acid position that is known to be pathogenic. Those codes are all considered as component of the bioinformatic analysis and are not separately applicable. So all these codes are not present in the BSc 1 and 2 guidelines. Next slide. So everything I just told you is summarized here in this flowchart. If you start, for example, with a missense variant that does not have any predicted impact on splicing and is not inside a functional domain, you end up at BP1 strong, likely benign. If it is in a functional domain and it does predict to have an impact on splicing, you can apply PP3 and perhaps PS1. If it does not predict an impact on splicing, you can apply BP4. And this is also a figure from the guidelines. Here are the exact values again, what you expect for Basedell and for Spice AI to apply these codes. And the same for silent variants and intronic variants. I'm sorry. So this is a figure, and that is in the guidelines, and you can use it, and you can print it out, and it's very easy to apply. Next slide, please. If you look now at the missense variant from run 10, the alanine 1279 threonine, there is functional data from the Baumann paper that this variant is neutral. So under ACMG BSc 1 and 2 and CAMVIC, you can apply BS3 at a strong level. However, as this variant is outside the functional domain, you can use BP1 strong under the VSEP guidelines and BP1 supporting under the CAMVIC UK guidelines. And the last one is a likelihood score, and that is identical in both guidelines, but the UK guideline says BP5 and the VSEP guideline says BS4. And of course, you come up with a benign variant under these conditions. Next slide, please. However, this is a missense variant, which is not present in NOMAD. So you can apply PM2 supporting under VSEP and PM2 moderate under CAMVIC UK. It is outside a domain, outside an important domain, so you can apply BP1 strong for the BSc 1 and 2 VSEP guidelines. But BP4 under the CAMVIC UK guidelines is not applicable as the level is too high for that. So you cannot apply BP4. So for this specific example, if you use CAMVIC UK, you end up at a cold fuzz. And if you apply the VSEP rules, you end up at a likely benign score already because of the BP1 strong standalone criterion. Next slide, please. And now I hand over to Claire.
Next slide. We tried to summarize the main differences against the Enigma VSEP guidance and the current CAMVIC UK BRCA 1-2 specific interim guidance. So we've divided them up. So these are differences which have quite a significant impact on the score. And actually, there was concern around these would potentially result in downgrading if we moved full scale across to the Enigma guidance from using the CAMVIC UK guidance. Next, so the first one is allowing use of PM5. So we still allow use of PM5 as sort of in the spirit of the original ACMG. So we specify moderate and supporting depending on the reference variance and the difference in score of the in silico tool, but either which way effectively you lose one or two kind of Tabtigian points, either effectively a supporting or a moderate. Next animation. Again, we allow PM1. So again, applied at moderate or supporting if it's at a key amino acid residue, moderate, or if it's within one of the key domains at supporting. So again, this has come out of the Enigma VSIP. So again, this would be a potential to lose 1 or 2 points at moderate or supporting. Next animation. BP5 and BP6, as Arjun explained, we previously allowed reputable classifiers. It's now just a question of location and liaising with Miranda Durkee. There's no reason actually we can't move these codes to the same places as the Enigma, so that removes a discrepancy. And we also allow PM4 and BP3 again in the spirit of the sort of broader historic ACMG. So again, that's a discrepancy. Next slide. And again, it's unlike, it's very low frequency, but PS2 and PM6 we still have included as per the original ACMG should there be de novo observations, but we will recognize that's highly unusual. Next slide. So again, these are again places where it's going to be a high impact with potential loss of points, and the big one here is PM2. So as Arjun highlighted, Enigma only allows supporting, we still allow moderate or supporting. So again, that's potentially quite a significant distinction. We again had specified using female controls only because again it's around sort of observation. We're talking about sort of female specific cancers. Next slide. And then again, these are criteria which are scored differently. So again, potential for impact and downgrade. And again, as I've highlighted, PS4 is the main one here. So carry on, next animation. Yeah, so again, we allow a broader range of scoring. Next slide. And again, case counting, next slide. And then PP3, again, potentially we are a little bit more permissive. Next animation. Because we don't specify domains, but as Arjun indicated, Revel and Basedell, they both come out as very high performing in all of the cross-tool analyses. So sometimes Revel will be higher, sometimes Basedell will be higher, and sometimes one will be over the threshold or the other. So that may not be a major impact on points for variants occurring within the critical domains. Next slide. Okay, I'll hand back over to Arjun.
Yeah, no. I'm sorry, my video is working. Yeah, it works again. Just a summary, what we have covered the last hour, an overview of the Enigma guidelines compared to the Canvig UK guidelines, and a review of the resulting differences in the coding and the classification of different variants. As you can see, I think the differences are minor, but still present, and still room for confusing coding, especially in the classification of variants. Next slide, please. And I hand over now to Cindy, I suppose, or Simon.
Thank you, Aaron. It's me. Thank you for that. Thank you both very much indeed for such an educational, great explanation of how the guidelines have come about and also how to apply them, but also the differences between the two. So I think my question to you both is, which one should individuals use right now when there is a difference between classification for a particular variant? Claire, I'm going to come to you first.
I would use whatever guidance you're using for classifying variants in your lab. So as I emphasized, we would seek to, in the UK, move towards consensus ACMG, and then that's also moving towards the disease-specific VSIP guidance. But we are just in a period of pause, and that is why we are out of sync. But I very much hope both the broader ACGS guidance and then Canvig over the next sort of year, 18 months, will be able to get more in line with the new ACMG and therefore the specific VSIP guidance. But I think for the moment I think the logic would be to use whatever guidance or combination you're using day to day for classifying variants. And then I think the marking of the ACMG does encompass using all of these different classification systems. And just to emphasize, working with Miranda and various other of the senior clinical scientists behind the scenes of CAMVIG, we have done some updates. They're quite minor, but we will release the updated version of the CAMVIG specific guidance. It's got a little bit more around thresholds and when to use UK Biobank and that type of thing. So there's nothing that dramatic, but we will release that ahead of the EQA round.
Fantastic, that's great. And if you can give us messaging, we can help get that notification out. So continue as you're doing, but be aware of the new guidance coming out as and when it's available. Thank you for that. So could we just pop back a slide, please, Amy, just to say that run 11 of the BRC1, BRC2 and the other HRR gene variants EQA will be going live in October, so for the calendar month of October. Registration is now open and you can use this link here or contact either EMQN Central Office or the GenQA office, and we can send you out the link and give you any help and advice if you haven't logged on before. And we'll be using the new Genie system going forward, so hopefully that will make the experience easier for participants as well. So thank you, and please get in touch if you need any further information around the EQAs. So if we just move on then, Amy, I see Simon, we've got a Q&A now and we've got lots of questions coming in. Do you want to kick us off?
Yeah, I'm just been triaging them as they come through. So
yes,
yeah, so thank you to all of you for adding your questions in there. So please do keep them coming. We would ask though that if you've got a specific question about a particular classification coding, for example, that you do preface your question with what classification coding you're looking at. There's been a couple that come through. It's sometimes difficult to interpret what question you're asking. So please do give us a bit of clarity there to allow us to talk to Claire and to Arjun about exactly what you're asking. I've got a sort of general point for both of you, just as a sort of kicking us off and starting us off. Have you come across any examples where the classification of a variant using the new Enigma guidelines is categorically, and I mean completely different, or reaches a different classification than the existing guidance? So, for example, where you might get a VUS versus a pathogenic, and how do you think we should address cases like that, which may have an impact on patient management?
Well, that is a very, very good question. And I know for the people also participated in the EMQN panel HBOC test that was recently published now. The first variant in there was classified as likely pathogenic according to the CAMVIG rules. But I looked at it and it had an occurrence of 1 male in NOMAD. So on the basis of that, PS1 PM2 could not be applied, as there was 1 male present in NOMAD. The UK doesn't count males, so that's still 0. But the VSEP guidelines do count males, and that was 1. So strictly speaking, following those rules, you came up at the VUS. And that gave also, I think, one of the reasons that was quite a discussion on that variant, whether it was a VUS or likely pathogenic variant. I hope we do not have too many of those variants, as that will be very confusing. And I do not recommend downgrading your variant on the basis of a novel guideline, as the difference it is all a matter of likelihoods. In this case, the likelihood of this variant being pathogenic just slightly dropped below a agreed level, but a completely just agreed level. There's no true science whether the level of evidence needs to be 95% or 94%. So I would recommend not to go too quickly in changing classifications because of a novel rule. Which is
obviously I think that's a very valid point, Arjun. It's a worry or concern here, I suppose, from the user groups about these. I mean, I would call them edge cases because hopefully, as you say, they don't occur very often. But there is a likelihood of potentially that coming in. Claire, did you have anything you want to say to that at all?
Well, no, it was just to highlight. We did have a working. Well, we had a workshop in by CAMVIG, and we also have this national MDT, which CAMVIG is predominantly clinical scientists and some clinical geneticists, and our national MDT is predominantly the clinical geneticists and some clinical scientists. So we had working a workshop in the national MDT and then another one in CAMVIG around reclassification, and talked about, and we published a paper which does at least sort of put out some guidance around, so it's variants where you shift across the actionable threshold. And as Arjun said, it's only 1 point, and the actionable threshold is completely arbitrary.
Yep.
And we say that it's 90% likelihood of pathogenicity as if we're that precise. And then if you have 5 exponent points, evidence points as per the Tapetigian system, you're a VUS. If you have 6, you're likely pathogenic. So there's this dichotomy in the clinical action for what can be a very small, it can just be, you know, a Revel score that's just one side of the threshold while the Basedel is the other. So again, we give some recommendations when things are making small moves across this actionability threshold, that you don't go full scale in contacting all your old families or whatever. But it is certainly something that, as we have emerging new evidence, as we have guidance that's evolving, as we have different sources of guidance, there will need to be local policies around how you deal with what will be minor shifts that just happen to flip it one side or other of that actionability threshold.
Fantastic, thank you both. Sandy, do you have any questions you want to bring up?
Yeah, I think we've got one here that I'm going to come on about reclassification, but there's quite a few questions going in the chat on the same theme as to, are these guidelines appropriate to use for somatic variants? Now, my view would be no, they are very much germline focused guidelines, and we have the AMP-ASCO guidelines for somatic, and because we have that level of whether or not they're clinically relevant within that cancer type. But Claire and Arjun, I'd be interested to hear your thoughts. Claire, you want to come in first?
Well, yes, that's good, because this is actually, it's because essentially for BRCA1 and 2, you're classifying a tumor observed variant.
Or yes, for those two genes.
With the view of using it as a germline variant. So that's a bit different to, you know, I don't know, classifying an EGFR variant you're finding in the tumor. Yeah. So I think that perspective is different. So I think probably, and then there's this awkwardness because you've got your somatic classification, which is all about actionability. So the whole framing is very different versus your germline systems, which are about pathogenicity. But I think in these instances, you are classifying it in regard of taking it forward and using it in the germline. So there's no point having one classification for the somatic system, which then when you confirm it is indeed germline in origin, it then has a sort of, it has a different pathogenicity classification. So I would say for BRCA1 and 2, you classified tumor observed variants in manner of how you would classify them if they're found in the germline. If they are likely pathogenic or pathogenic, it is then relevant to go on and do that germline confirmation. And we published some data in Annals of Oncology showing really for most tumor types, it actually doesn't vary as much as you'd have thought. It's around about 80%. That if they're at a reasonable, if they're at an appreciable allele frequency in the tumor, they're likely to be germline in origin. Yeah, I agree with that, but I think you have to put it in the clinical context. So it's not fair to that you could, because we see in a lot of our somatic EQAs that germline guidelines are used to apply for variant pathogenicity, which is fine to determine the pathogenicity at the level variant, but not in that clinical setting necessarily, because you've got to bring in the actionability side as well. So it's very complex, and just in there, the somatic variant classification is even more challenging and disparate across participants as well. So yes, I think
we haven't even addressed that yet.
If you take into account that for PARP inhibitors, for example, you need a pathogenic or likely pathogenic variant.
Yes.
It doesn't matter then if it's somatic or germline origin. And in that case, you should use this a comparable approach to come to your classification. And indeed, it is very confusing if the pathology report mentions a clinical relevant variant, and then the genetic lab comes back, oh, it's a VUS. That is extremely confusing. And I think for these genes, especially BRCA1 and 2, I would strongly recommend to keep the germline guidelines. This is a germline guideline at hand, because it is, as Claire says, possibly a sometimes likely germline variant.
Absolutely.
And also there's a sort of workflow. So again, we in the so it was an ESMO working group, what was written up in Annals of Oncology, that you can have a sort of pragmatic filtering for your workflow. So you then get variants that are found in the tumor that are putatively of germline origin. Before you go to the patient and talk to them and get the germline sample, at that point you want to do a formal classification to ensure that your sort of automated pipeline, that it would still formally be likely pathogenic or pathogenic, because there'll be nothing more confusing or nonsensical to talk to a cancer patient undergoing active management, scare the bejesus out of them, you know, do all the whole germline talk, and then go, actually, it's VUS, so we won't manage you anyway. You know, that would just be ludicrous. So I think it's really important that there's a pause. You've done the tumor analysis. It's got a reasonable VAF. It on automated pipeline appears to be pathogenic. You know, either it's truncating or it's, you know, it's in ClinVar or whatever. You pause, you do your formal classification, you only talk to the patient and the clinical team if it's something that would be taken forward. Would you agree, Arjun?
Absolutely, 100%. Yeah.
Brilliant. Thank you. Really helpful advice. So that brings me on, Simon, to my last question. I wanted to bring up about ClinVar. So what do we do with variants that are reported in ClinVar right now as either reviewed by the expert panel and are benign or are pathogenic? So should we be routinely now rechecking them on the understanding of new guidance coming out?
Like
do you want to come in? Go on, kick us off.
Like I just mentioned, I wouldn't now reclassify all your previous variants if you classify them under a different system. And I don't think that's very useful to do. But if it comes up now in a new patient, obviously you will normally reclassify your variant under the guidance that you have now, but not retrospectively going back to families to make a lot of noise about a reclassification if it is not based on new data, of course. If there's new data, a functional assay that is clearly stating it's not pathogenic, you've, of course, a different story. But in generally speaking, I would recommend now going back to recalculate all your existing variants.
Great, thank you. Claire, do you agree?
Yeah, so that was in our, we got into like this really overly convoluted schematic in our guidance paper about reclassification. So there were sort of three factors. There were what was driving the new points. So is it new data or is it just a change in guidance? What's the magnitude of the change and where did it shift it to? And these sort of three factors would determine, like Arjun said, do you go back to all your old families and get them in? Do you just pause and deal with the patient in front of you? And we did prescribe a time window over which you should wait and just see what new evidence comes out and let the ground settle. So I completely agree that just going back to all your old families knee-jerk for what is a kind of shift in points, particularly arising from new guidance, is not helpful for anyone. I remember challenging or asking specifically Stephen Harrison, who's one of the big SVI people around, and it is the SVI mantra that whenever you encounter a new variant, you should review the evidence and reclassify. Now, if it's already been classified by Enigma and it's got, you know, a huge burden of evidence, it's a perfunctory kind of couple of minutes, you know, just eyeballing. But the notion would be there could be new data that's emerged at any point for any variant, so you should always look again. So that is because actually the VSIPs don't like that. They sort of feel that they should, or some of them, they should be providing the authoritative classifications for their genes, and lab users should just take them verbatim. But the central SVI ClinGen position is that every person who's signing off a variant classification should have reviewed the evidence each time. Now, labs may have a procedure that if it's been classified locally within 3 months or 6 months, it's a reasonable position not to look at it again. And the balance of probability, that's an absolutely kind of appropriate pragmatic approach.
Great, thank you. I think there's a big breath of relief, sigh of relief that just gone across the globe after that statement. Thank you. Simon, back to you, please.
Thank you, Sandy. So we've got quite a lot of questions coming in, very, very specific to particular variant classification criteria, of which I suspect most of them will pick up actually outside of this webinar, because they're so detailed. It would be better to have a written response rather than perhaps a verbalized response on the hoof. But there's quite a couple of which I picked up about, for example, case control data, which is interesting. So I will put one of them to you, which is about BS1 and PM2 calculations. And then maybe I've got a more general question about control data in specifically. So probably Arjun, I suspect this is more addressed to you, but what's Enigma's rationale to the use of frequency of female and male non-cancer controls for BS1 PM2 calculations?
I think the easiest answer is that that was not really thought through. They used the FISET used the available data set, the easiest to apply data set, and the FAF is easily applied for the complete group, males and females together. And for that they calculated the appropriate weights. So it is the assumption that were made have been calculated that there's a likelihood score in one direction or another, so appropriate on that data set. So you can only apply the data set that was applied when validating that specific code. So that's why you have to use for the FISET classification, you have to use the complete data set as the code was validated on that. And now you can say, well, it's perhaps better to use the female data set, as those are where the cancers occur for BSC1 and 2 mostly. Perhaps that's true, but it was not validated on that specific data set. So yeah, there is
a legacy issue as much as anything else. That's what you're saying. Yeah, Claire, did you have anything you wanted to say to that talk?
I think it's because we took Nomad out and separated it out, but I think it's only relatively recently that it's been publicly available to flip between male and female and so forth. So I think, as Arjun said, it's a sort of practicality in terms of data availability. I always just the phrase cancer-free controls, this is Nomad with TCGA taken out, which TCGA was really enriched for, like, you know, there were like, I don't know, like tons of paragangliomas in there and so forth. So it was this really odd data set to contaminate the rest of Nomad with. The remainder of Nomad is not cancer free. It's essentially a sort of funny amalgam, but for the sake of argument, it should, if you take out TCGA, have as much cancer in as the general population.
Okay, so that leads me on to my next question then, because I think what you're defining there from both of you is that there is a difference in terms of the way control data is incorporated or applied to the classification guidelines. So do you know whether there's a plan to review or modify current guidelines to incorporate more appropriate case control data sets and therefore enable more accurate classification as a consequence?
I would say it's a very small difference. So it's intellectually slightly more satisfactory to use female controls. In practice, it makes a very small difference. But like everything else, there are the edge case variants that, as Arjun described, they'll be the ones where it makes the difference from one single individual. So again, I think in terms of CanVig UK, we were specifying what we felt to be the best use of the data. But again, we need to converge on a single approach. And I think either females only is a little bit better, but it's not a major difference.
Right. Okay.
And the problem will solve itself, as in the new version of the ACMG rules, PM2 is altogether skipped. So the absence of variant in Nomad is no longer any evidence
Yeah.
at all towards pathology. Of course, it is towards benignity, but not towards pathogenicity. And also, Nomad is growing. So at a certain moment in time, a variant will pop up in Nomad. So yeah.
And also, UK Biobank is going to be absorbed into Nomad, which I think will help. So essentially, my understanding of the new ACMG, because you have a case control signal, which can either be towards pathogenicity, if there is a high frequency in cases or controls, or towards benignity, if there's a high frequency in controls than cases. So effectively, PS4 and PM2, and in fact BA1 and BS1 can all be incorporated in a sort of that single observation, and potentially if you put all your data sets in one place, that gives you the most power.
Yeah, I wasn't mentioning the specifics, but I was aware of the fact that that data is going to be incorporated into Nomad, and so it will, it might it might have a significant difference potentially.
Yeah, I mean, I think all this speaks to the fact that that I can't see a point in the next 5 years where it's all nailed down, done and dusted, and we can say, oh, there'll be no more changes now. So I think what we do need is local or national systems by which we can recognize the fact that this will be evolving, there will be new data, the rules will change, the available data will change, and there'll be some variants which these changes just flip them across that actionability threshold, and we need sensible ways of dealing with essentially new data flipping across an absolutely arbitrary threshold.
Yeah, I would agree.
And we also need to consent our patients appropriately, because again, I think historically the clinical geneticists sort of treated lightly pathogenic and pathogenic the same, and gave very factual sort of communication to the patient. And I think although it's a bit awkward, that the patients do need to be made aware, particularly for lightly pathogenic variants, that there is a small but a likelihood that it could be down classified, and they may be, or just more broadly, they may be recontacted if new evidence is available.
Yeah. I think we've generated some lively discussion there, which is fantastic. Okay, Sandy, over to you.
Yeah, I'm just going through the guidance here. A couple of people have been asking Claire for a reference for the paper that you are mentioning, so we'll be able to get that out to people as well. Also,
and we can send out the PDF. That should be fine.
That would be super. Yeah, very.
It might be illegal, but I'm sure it's fine.
Well, if it's publicly available,
we're all friends. Yeah, I think it might be behind a paywall or something.
We've got 336 friends on the call, so
we're friendly people.
Yeah. One question, because we were all using Revel and we said this was the way forward, but now we've gone to Basedell. So is there an easy way to get the Basedell score? What's the way of Ajahn nodding furiously? Fantastic. Please help.
This is the good point to really promoting BRCA Exchange. BRCAexchange.org contains all the information. It has specifically put the Basedell in, and it also indicates whether or not the variant is in an appropriate domain. And if it is not, it is grayed out. So it still gives the Basedell, but it is grayed out, indicating do not even use, just apply BP1 strong, as long as your Splice AI prediction, which is just below that score, is also below 0.1. So yes, all the information is available, and I cannot stress enough to use BRCA Exchange as your starting point in variant classification for BSc 1 and 2.
I think I'd also just put a shout out as well. So BRCA Exchange has some absolutely fantastic presentations of the data, and really, really useful to explore that. Canva UK, if you join you will all be diagnostic users, so you can register, and it's really quick. But what that means is you get access to the forum, and then if you click on a variant, you can send out an inquiry, and it says a nice little email with the variant name in the header, and that goes to the full Canva UK user group, which spans 6 continents, I believe now. But it's got pretty much all of the cancer genetics clinical scientists in the UK use it. Lots of guys in the Netherlands and Belgium use it in particular, but we've got people at Memorial, Vanderbilt in the States as well. And you can ping out and everyone gets the email. You will get a few emails. It's not loads, it's maybe half a dozen a week. But there's some nice exchanges, and you can particularly for genes like Lynch genes, you can ask if people have cases or tumor data, and there's a ton of data out there that's unpublished. But a lot of people would use it for BRCA variants to bounce off their proposed classifications, and particularly ones that are a little unusual or whatever. And it's just a nice sounding board to get other opinions, and even reassuring if you say, oh, we're planning to classify this as likely pathogenic. If you don't get anyone shouting back saying that's lunacy, it is in itself a sort of a way of sounding out a very broad set of people who are in the same field as you. So it's Canvar UK, and then go to register. We don't let people who aren't involved in diagnostics register. So it's not got lots of kind of people doing mouse models or kind of hassling you with irrelevant questions. It will all be around variant specific questions from like-minded people.
And Claire, that sounds a really rich resource that's everyone needs. Would you be happy for the EQA schemes to signpoint people in that direction on our next EQA summary report that goes out?
Yeah, that would be great. And we can also circulate from the meeting the link, although you can Google it. And sorry, I can't remember if I said it, but so it's also got lots of resources on it. So it's got, I think, 12 in silico tools. So it's got all the Splice AI scores, the Basedell scores, the Revel scores, the gene-specific aligned GD scores. It's got the whole of Nomad. You can flip between females and males, and TCGA and non-TCGA. It's got UK Biobank extracted, which is very useful because that's quite difficult to access unless you have signed up access to it. It's got data from our national NHS testing, which is a numerator and denominator of the frequency of variants as they've been encountered across all the English diagnostic labs. It's got all the functional assays relevant to BRCA in there. So it's a sort of designed to be a one-stop shop for cancer susceptibility genes only, but hopefully useful for those.
We have an audience participant who's just dropped us a message in the Q&A, say highly recommended, and that's from Argentina. So clearly it has a global reach, which is fantastic to see.
I may have to come and do a site visit to check they're using it correctly.
Okay.
Some items, I think the frequency of variants within the UK labs is not accessible for non-UK users. But most of the information
you can access it. You can't see which labs they've been seen in. So you can get a summary numerator and denominator for all observations, and a numerator denominator for those for white British observations. So that's then comparable to the non-Finnish Europeans or the white British and UK Biobank. UK users can see if it's been seen in Sheffield or Exeter, but that's probably as a starting point not particularly of interest to non-UK users, but that was the kind of deal we had to cut around individual patient identifiability. But you can see it's been seen 14 times in, I think it's the new data are just about to go in. So I think we've got sort of about 80,000 proband. So they are probands who earn themselves a BRCA1 and BRCA2 test in the NHS. So they are reasonably enriched. But you have a numerator denominator for the frequency of observations.
Sounds like a fantastic resource, which obviously by definition is free to use for clinical diagnostic laboratories, and I'm sure it will make a difference.
Anyone can access most of it, but to be part of the chat community, we restrict that to clinical diagnostic users just to stop people getting too many extraneous questions.
Fantastic. Sandy, I think we are coming up to the end of our time, actually. I think we should probably call it a day. I think as normal, we would normally pick up any of the specific questions in our summary scheme report at the end, which comes out at the end of the either at the end of the EQA run. So we will do that for those very specific questions that you've asked us in the chat that we haven't addressed in today's meeting. Have we anything else we want to cover at all before we move on to the thank yous?
Just to say that the registration's open for the next EQA run, and it'll be open and live for participation during the month of October. And then I believe we've got a follow-up webinar to discuss the results and findings as well. So I'm sure we will speak to you before the end of the year.
Fantastic.
And then to reassure, the use of the ClinGen guidelines or the use of the Canva guidelines, both are accepted in Run 11.
Absolutely. Thank you, Arjun, for that clarification. Right, let's call it a day. So thank you to all of you who've dialed in today. We had nearly 400 of you dial in, which is absolutely fantastic. Shows we're getting to the places we need to. So please do encourage your colleagues to dial in next time. So a big thank you to today's speakers, Arjun and Claire, for their fantastic talk. I hope you have found it both educational and informative, and we sincerely hope that it helps you rationalize some of the differences between the guidelines that we've highlighted today. Thank you also to the team at AstraZeneca and MSD for organizing and supporting this webinar. And lastly, but thank you also to my co-host Sandy, fantastic job, and we'll look forward to speaking to you all in November at the next webinar, which is the last one, which summarizes Run 11. So please do, if you want to participate, get in contact with the GenQA or EMKN offices. We'll sort you out for a registration for the EQA, and we'll look forward to seeing you all in November. So thank you all once again, and have a great rest of the day.
Thank you. Thank you.
Thank
all.
you.